You know, your world, the one with solid coffee cups and car keys you can actually find, it all runs on a set of rules we call classical physics. But what if I told you that entire reality is, well, just an illusion, a stubborn habit the universe has, a habit that we can teach it to break? Yeah, let's get into it.
So, back in 1984, scientists ran an experiment on an object you could literally see with the naked eye. And the results? They were a total shock. Classical physics, the rulebook for our everyday world, predicted one thing would happen. But what they actually saw? It was something else entirely. It completely defied all expectations. And you know what it matched perfectly? The weird, probability-driven predictions of quantum mechanics.
And right there, that's the impossible question we're tackling today. If an experiment almost 40 years ago proved that big things, macroscopic things, follow quantum rules, then why does your world still look so stubbornly normal, so classical? Why aren't things popping in and out of existence? That is the mystery we are going to solve. To get to the truth, we first have to tear down the official story. You know, the comfortable explanation we're all taught about how the universe is supposed to work. The textbook answer is pretty simple, right? Quantum is for the tiny stuff, atoms, electrons, all that. Classical physics is for the big stuff, you, me, planets, you get it. It's a very neat and tidy division. And as that 1984 experiment proved, it's also completely wrong. Okay, so this is a really critical point. The 84 experiment wasn't just looking at one lonely little atom. Nope. They were measuring a macroscopic variable. Think of it as the collective synchronized behavior of billions and billions of electrons all moving together in a superconducting circuit. The specific thing they measured, this phase difference, was like the collective rhythm of a huge quantum choir. This was not a microscopic event. This was the quantum behavior of a crowd. The experiment was basically set up as a cage match between two different realities. Imagine you've got a marble stuck in a bowl. Now, the classical way to get it out is to give it enough of a kick, enough energy or heat to pop it over the rim. We call that thermal activation. But quantum mechanics has this bizarre cheat code, tunneling. The marble can just appear on the other side. It punches right through the wall of the bowl as if it wasn't even there. The experiment was designed to ask a very simple question: which escape route would the system take? And the answer didn't come all at once. It came like clues in a detective story. 3 huge revelations that completely rewrite the rules of reality as we know it. All right, revelation number 1. This was the smoking gun. The hard data that proved without a doubt that the classical world had just failed the test. This quote from the original paper, this is the moment everything changed. What the researchers found was that as they got things colder and colder, this system stopped escaping by being kicked over the barrier. Instead, the escape rate just flattened out. It didn't care about heat anymore. It was escaping through a purely quantum process, macroscopic quantum tunneling, or MQT. It was literally tunneling through reality. The quantum world wasn't just for atoms anymore. It was right here, in our world. But, okay, if the big world is quantum at its core, why don't we see it? Revelation 2 points the finger at the culprit, a kind of universal force of censorship. It's a process called quantum dissipation. The easiest way to think about it like this. For anything to act quantum, it has to be perfectly, and I mean perfectly, isolated. But in our universe, everything is constantly bumping into everything else. It's leaking information, it's leaking energy, and this constant interaction, this dissipation. It's like the universe is constantly measuring the quantum system, forcing it to pick one single, boring, classical state. It's this relentless universal pressure that just smothers quantum weirdness. The final piece of the puzzle showed that this force, this dissipation, isn't just some vague idea. Its power can be measured, it's predictable, and it is absolute. See, decades of work after that first experiment proved this really simple, inverse relationship. The more a system is connected to its environment, the higher the dissipation, the less it can do quantum stuff. High dissipation just crushes the quantum tunneling rate. And here's the kicker. The classical world you and I experience every day, that's just the result of maximum, totally overwhelming dissipation. And that insight, that right there, it changes everything. It reframes our entire reality. It's not a set of fixed laws we're living in. It's an ongoing battle. So get this. The big divide between the quantum and the classical world, it has absolutely nothing to do with being big or small.
It has everything to do with being isolated versus being constantly tangled up with the environment. The reason your coffee cup doesn't just tunnel through your desk is because it's constantly being bombarded by air molecules and photons, and it's touching the desk itself. All of that interaction forces it to be in one single, predictable, classical state. This timeline really puts that struggle into perspective. 1984 was the first glimpse, a peek behind the curtain showing us macroscopic quantum reality was possible in a carefully isolated box. The decades since, they've been a relentless war to understand and defeat dissipation. And the prize for winning that war? Well, according to predictions, learning to control this effect is the next frontier of physics. It's the key to unlocking real quantum technologies, and it is absolutely Nobel-worthy. So where does that leave us? What does it all mean? It means our entire perception of reality has been fundamentally wrong. It's not a law. It's just an artifact of our noisy environment. I want you to really think about that for a second. The classical world, with all of its solid, predictable, boring rules, it's just a habit. It's the default state that gets enforced by all the constant, chaotic noise of the universe. It is not a fundamental, unbreakable law of nature. It's just the default setting. And like any setting, it can be changed. And if that's true, it means the entire project of modern quantum technology, from sensors to computers, all of it, is actually an act of engineering reality itself. Every quantum computer is a purpose-built little pocket of the universe, meticulously shielded from dissipation, where the true underlying quantum laws are finally allowed to run free. We are, piece by piece, learning to break the universe of its classical habit. Which leaves us with one last, really provocative question. Right now, we're building these isolated islands, where a totally different version of reality is allowed to operate. What happens when those islands grow and become continents? What happens when all these little pockets of quantum reality start to connect?